Hey everyone, and welcome to this explainer. Look, if you thought artificial intelligence was just about chatting with a bot or generating some funny images, you are missing out on what analysts are calling the biggest wealth transfer and systemic tech realignment of the decade. Today, we're unpacking a massive shift in the tech sector. We're talking about AI moving out of the cloud and directly into the physical world.
So let's kick things off with a pretty critical question. What actually happens when AI gets a physical body? I mean, how do you build an operating system not just for a personal computer, but for an entire autonomous, heavy-duty factory? That right there is the multi-billion-dollar question that the world's biggest tech and industrial giants are racing to answer as we speak. To really wrap our heads around this shift, we kind of have to contrast the era of generative AI against this entirely new era of physical AI. For the last few years, generative AI has been the star of the show, right? It creates text, it writes code, generates media, but physical AI? This stuff interacts directly with real-world infrastructure. It simulates actual physics, operates multi-ton machinery, and enables real-time adaptive manufacturing. It's literally the difference between an AI writing a recipe for you and an AI actually running the entire industrial kitchen.
All right, let's get into Section 1, the Industrial AI OS. To see how this is all playing out, we've got to talk about the massive January 2026 announcement from Siemens and Nvidia. They didn't just announce a new chip here, they announced a co-developed industrial AI operating system. This expanded partnership is built from the ground up to enable fully AI-driven adaptive manufacturing. So they're deploying this brand new OS right alongside a suite of incredibly powerful new tools designed to run the factories of the future. Now, one of the wildest tools they dropped is the Digital Twin Composer. Think of this thing as a hyper-realistic, high-fidelity flight simulator, but for massive manufacturing plants. Before a company physically moves a robotic arm or changes an assembly line, they simulate it first in this virtual replica. If the new workflow crashes or creates some huge bottleneck in the simulator, it costs absolutely nothing. But if the AI optimizes it and it works perfectly in the digital twin, boom, it gets deployed flawlessly into reality.
And you're going to want to remember the number 9 here. Because alongside that overarching operating system, Siemens and Nvidia launched 9 new AI-powered industrial copilots. And to be clear, these aren't just basic chatbots. These are highly specialized digital assistants engineered to streamline day-to-day factory operations, manage incredibly complex supply chains, and actually assist human operators right on the floor.
Moving right along to Section 2, the underlying tech architecture. Because if you want to run an entire factory autonomously, you need an entirely new way for computers to process the physical world. Enter NVIDIA's Cosmos 3. This is a frontier model, and they are officially calling it the world's first fully open Omni model for physical AI. And what Omni actually means here is that it's capable of understanding and generating text, images, video, audio, and physical actions, all at the exact same time.
When you look at what this thing can do, you quickly see why it's a total game changer for heavy industry. This physical AI can literally watch a live video feed of a factory scene, reason about how physical objects move, and accurately predict what is going to happen next. It understands gravity, momentum, spatial awareness, the whole shebang. This is exactly the technology required to safely train robots for really complex manufacturing tasks. Plus, it's super versatile. It can be deployed in massive supermodels for complex reasoning, all the way down to nanomodels designed to run directly on smaller edge devices.
And if you want to see how insanely fast this is all moving, just look at this timeline from early 2026. January 5th, NVIDIA launches the Rubin hardware platform and those new Open Cosmos models. Literally the very next day, January 6th, they announced their Alpamayo physical AI is going to debut as autonomous driving tech in the Mercedes CLA. And then just 3 days later, on January 9th, they dropped the Industrial AI OS with Siemens. I mean, in less than a week, they laid the hardware, software, consumer auto, and heavy industrial groundwork for physical AI. Just wild.
Which brings us to Section 3, the systemic realignment.
Look, zooming out for a second, this partnership isn't just happening in a vacuum. It is part of a massive global capital mobilization aimed at completely rewiring how enterprise computing works. As industry reports are calling it, we are in the middle of a systematic realignment. The whole era of just sending all our data to some massive cloud server farm to be processed, that's changing. There's a fundamental redesign happening right now in physical computing architectures. The goal is to run multi-step autonomous agentic software locally right where the physical work is actually happening.
And that perfectly tees up edge silicon architectures. Why is this so crucial? Well, think about it. An autonomous factory making precision parts absolutely cannot afford a 2-second latency delay while it waits for a cloud server to tell a robotic arm to stop moving. That's a disaster. And on top of that, industrial giants are definitely not going to risk sending their most sensitive, proprietary manufacturing data over the internet. So we're seeing this massive shift toward edge silicon, basically running these powerful AI models right there on the factory floor.
Of course, security is a huge deal here. To make sure that localized industrial data stays locked down, these companies are using tools like the OpenShell Secure Runtime. Co-developed by Nvidia and Microsoft, OpenShell basically acts as a local security checkpoint. It makes sure that any sensitive proprietary data or trade secrets are sanitized and completely contained within the operating system, way before anything ever touches an external network.
Let's shift gears to Section 4, Hardware for the New Era.
So, for years, GPUs, graphics processing units, have totally ruled the AI training boom, right? But this heavy pivot toward edge computing and localized agentic AI is completely upending hardware demands. As analysts point out, running these autonomous multi-step agents locally actually requires different hardware logic. Instead of needing 4 GPUs for every 1 CPU like we used to, agentic inference brings it much closer to a 1-to-1 ratio. This shift is quietly returning the good old CPU to a position of incredible prominence in the data center and out on the edge. And this exact rebalancing of hardware power is why Siemens isn't only partnering with Nvidia, they are simultaneously deepening their massive collaboration with Intel. They're exploring purpose-built Intel silicon specifically designed to handle the highly varied compute requirements of edge devices and factory robotics. From high-performance computing all the way down to chip lifecycle management, Intel is really positioning its CPUs to be the bedrock of this new local inference era.
Finally, Section 5. Future of Adaptive Manufacturing.
So tying all these threads together, the operating systems, the physical omni models, the edge hardware, what's the ultimate takeaway for global industry? Well, the new blueprint is strikingly clear. Step 1, you simulate everything safely and cheaply in a virtual reality digital twin. Step 2, you process the intelligence and physics reasoning locally at the edge using models like Cosmos 3. And Step 3, you seamlessly execute the physical labor in the real world using those AI-powered industrial copilots and robotics. It's a brilliant closed-loop system of continuous AI-driven optimization.
But as this industrial AI OS takes physical computing to extraordinary new heights, and as these silicon partnerships reshape what machines can actually do in the physical world, it leaves us with one incredibly profound question. When the factory can simulate, reason, and execute flawlessly completely on its own, what role will human labor ultimately play in this next industrial revolution? It's a structural transition that's going to redefine the global economy, and it is happening right now. Thanks so much for joining me on this explainer, and keep questioning the future.